Hello, this is Mr. Collier, and today we're doing rational functions with quadratic denominators. Okay, so let's take a look at some of these. And let's do this without a calculator first, and then we'll check our answers with Desmos. Okay, so let's take a look at the first one, and probably the easiest thing to start off with is the vertical asymptote. Just to set the denominator equal to 0, and you get x squared equals 2, so x equals positive, negative, root 2 are the vertical asymptotes. Now the horizontal asymptote. Now if the degree of the numerator is less than the denominator, then you're always going to get a horizontal asymptote at y equals 0. Okay, because the limit as x goes to infinity, if you think about x getting really, really large, the denominator overcomes the numerator, and the denominator gets huge, so the value gets closer and closer to 0. So y equals 0 is a horizontal asymptote. And then, of course, the x-intercept and the y-intercept. F of 0 equals 0. Okay, so it does go through the origin. And that's actually going to be the y-intercept as well, so we don't need to calculate that. Okay, so let's start drawing this. Alright, so the asymptotes, let's draw some lines here at 1 and 2, 1 and 2, and maybe a couple of these. The vertical asymptotes are root 2, that's about 1.4. So you got x equals root 2, x equals negative root 2, and we know it goes to the origin, and there's no other y-intercept. I guess we could have shown that if we set it equal to 0. If we set it equal to 0, we get basically 0 equals negative 5x, x equals 0 is the only x-intercept. Yeah. Okay, so we know that there's going to be a horizontal asymptote at y equals 0. And now here's a slightly tricky part. You need to figure out if it's up here or down here. Okay? So what we can do is actually called a sign diagram. I'm going to pop it up here. And let's work this out. We got x. Let's put x down here. Then f of x. And the important points are negative root 2, 0, and root 2. Those are the places where we can change from being above the x-axis to below the x-axis. So if I plug in a number like 1 into this here, I get, well, the whole thing is negative, and I get 1 over a negative. 1 squared minus 2 is negative, so negative, negative gives you positive. So we can figure out that here, it's going to be, the function is going to be in the above the x-axis, and over here, if you plug in a number like negative 1, you actually get a negative, because you get negative, a negative in the numerator, negative in the denominator, all that's negative. So in between these two asymptotes, this is what the function looks like. Okay, it has to approach the asymptotes, it has to go through the origin, this side is positive and this side is negative, so it has to look sort of like that. Now root 2, bigger than root 2 would be a number like 2. So you plug in 2, you get negative, positive, positive, so the whole thing is negative. So that means this branch is like this. And over here, we've got a number like negative 2 would give you negative, negative, positive, all together gives you positive. Okay, you get this branch right here. So this is what the graph looks like. Let's take a look at Desmos and see if that matches. Yeah, that sort of matches what we have, right? Okay, so next one. This one here, you can factorize the denominator. So let's go ahead and do that. 2 over x plus 3, x minus 1. Oops, x minus 1. Okay, so now we can see what the vertical asymptotes are going to be. It's going to be x equals negative 3, x equals 1. Horizontal asymptote, again, if the numerator is, the degree of the polynomial in the numerator is less than the denominator, you're going to get y equals 0. And x-intercept, let's do y-intercept first. P of 0 equals negative 2/3. And there's no x-intercept. If you solve 0 equals 2 over x squared plus 2x minus 3, there's no solution. So this is all the information we have, and we're ready to graph it. Let's do that. So let's make a graph over here. I'll make a couple of lines. And then we've got vertical asymptotes at negative 3 and 1. So negative 3 is over here. X equals negative 3, and then 1's over here. We've got a horizontal asymptote at y equals 0. And we've got a y-intercept of negative 2/3. So that's about there. Okay, and then we could do a sign diagram, and I could do it right above these horizontal asymptotes too, so you can make it clear, or it doesn't matter. X, f of x, or I should say p of x. And we got the values, oh yeah, there's no x-intercept, so we just got the values of negative 3 and 1, right? Okay, so substitute a number between that. 0 is pretty easy to sub in. So I sub in 0. Actually, I already know this. I already know that value is positive. Okay, so the graph's going to kind of look like this, I guess. It does not go down this way. And past 1, we have a number like 2. If you sub in 2, you get positive here, positive, positive. Everything's positive. So we must have this branch right here. And I just realized I made a mistake over here. Look, that's negative 2/3. Oops. The y-intercept's down here. So you're going to get this shape. And, alright, so that's actually negative there. And if I sub in a number like negative 4, you're going to have negative, negative. It comes together to give you a positive. So it's going to be like this. Okay, and you should label your graph 0, negative 2/3, and now we have everything labeled. Okay, let's take a look at Desmos. That was 2 on the numerator, so it's this one here. So this is what the graph looks like. Notice this is not a parabola down here. It's just a curved shape, and it's got asymptotes. Okay, let's look at a couple more. This one down below, we've got a vertical asymptote. You're going to solve the denominator equal to 0. That's going to give you x equals 3 and negative 3 if you solve for x. Horizontal asymptote, the numerator less than the denominator, y equals 0. Let's get the y-intercept, sub in 0, we get 0. So it goes to the origin again. And if you solve 0 equals this, you just get one solution. So there's only one x-intercept, one y-intercept. So let's graph it. Let me draw a couple of lines. So let's draw the asymptotes and label them. X equals 3. X equals negative 3. It goes to the origin. So it's probably one of those that go like this. Okay. And then we could do a sign diagram. So x, f of x. So we have 0, negative 3, and 3. So we can sub in numbers like 1. Sub in 1, and we get a 1 divided by a negative is negative. And we sub in a number like negative 1. We get negative divided by negative is positive. And we sub in a number like negative 4. We get negative. And if we sub in a number like 4, this is going to be positive over positive is positive. So you can see this is positive over here, negative in this region. I forgot to label y equals 0. Sorry about that. And it goes from positive to negative, so it's actually going to go this way. Okay? And we can label 0, 0, and then everything's labeled. Okay, the next one, it gets a little bit interesting. Actually, let's look at the graph for that one first. Yes, so it matches what we just did. Doesn't matter about the steepness, just as long as you get the important points there. So for this next one, we've got vertical asymptote. Well, actually, let's factorize that. this equals 2x plus 8 over x minus 4, x plus 1. So that means the vertical asymptotes are x equals 4, x equals negative 1. Do I have that right? Oh, so that's a 4 right there. That's 3, 4 and 3. Sorry about that. This factorizes x minus 4, x plus 3. Okay, so that means the vertical asymptotes are 4 and negative 3. Okay, next, f of 0, or the horizontal asymptote is still y equals 0. F of 0 equals negative 8 over 12, which is 2/3. Okay, and is there an x-intercept this time? Let's check it out. I think there is. Okay, so we got x squared minus x minus 12. We can multiply both sides by this, so we get 0 equals 2x plus 8. And that means x equals negative 4. So we have an x-intercept this time. It is possible. Okay, so let's plot the asymptotes first. We've got x, let's do y equals 0 first. Don't forget that one. X equals 4, and x equals negative 3. Then we got the y-intercept is negative 2/3, and the x-intercept is negative 4. Okay, so let's figure out what the graph looks like, probably with a sign diagram. We got x and f of x. The important points are, well, actually we need the negative 4, and then the asymptote, then the other asymptote, and that's it. So in between 3 and 4, for instance, we have 0. Substitute 0 into the equation, and we get positive over negative times positive, so that's negative. And for 4 here, we can substitute in 5. If you substitute in 5, you get all positives. If you substitute in a number like negative 3.5, we get positive, negative, negative, so it's going to be positive here if I do negative 3.5. And then a number like negative 5 will give you a negative, 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 so we have negative. Now we can draw the graph. Over here we have positive, so it's got to go like that. Here we have negative, so it's all underneath the x-axis, so it must be something like that. Then we have positive between the x-intercept and the vertical asymptote. Alright, so we go underneath. And then we have negative, so it stays negative beyond this point, so and it goes towards the horizontal asymptote, so it must go something like this. And we should label the points, 0, negative 2/3, that's negative 4, 0. And I think we have everything labeled. Let's take a look at Desmos to see what it looks like. And this is what it kind of looks like right here, okay? And it matches our shape. It was a little bit more, interestingly, it was a little bit more skewed this way, but just a general shape is what matters. Okay, next week we're going to do this kind of like a real-life problem where you have an asymptote involved. We have C as the concentration of drugs at time t, given by this equation. Sketch a graph of drug concentration versus time. So we can do that on our calculator. Let's go to apps, functions, and type that in. 25t. Well, I'll type in 25x, x squared plus 4. And now let's choose our window carefully. Let's go to shift plot. X values are time, and this is in minutes after the drug is received. I don't know, it could go up to like 200 minutes, I suppose. And the concentration of drugs in milligrams, I don't know, let's try 100 and see what happens. Okay, plot, and oh, I went way too big. So we want to zoom in on this part right here. I should have done much smaller. So 0, I guess, is only after a few minutes. It must be, Yeah, maybe. Let's go 20 minutes. 0 to 10. Okay, let's click plot. Now we have a much nicer looking graph. Okay, so sketch the graph. I'll do that here. This is t and c of t. And I forgot my window. I don't know, I'll just graph it first. And the window I chose was 0 to 20. And I went up to 10. Okay, so there's the graph. When does the highest concentration happen? That is right there. That's the max. So we can just go to plot, click near the maximum, and then go to menu, function, extremum, and it gives you 6.25. 6.25, so that's after 2 minutes. And that's what the question is asking after 2 minutes. Okay, part C, what eventually happens to the concentration of the drug in the bloodstream? Well, what happens is, since the numerator, the degree of the numerator is less than the denominator, then the limit as t goes to infinity of c of t is 0. In other words, we've got a horizontal asymptote here. Okay, so it approaches 0. D, how long does it take the concentration to drop below 0.5? We can graph 0.5 and find this point of intersection to figure that out. Okay, so let's graph that. 0.5 plot, and we can't see it yet. It's way over here somewhere. Click menu, function, intersection, and it should be almost 50 seconds. Okay, so let's say 49.9 after 49.9 seconds.